Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's webinar you have a question for our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take probably around 10 or 15 minutes near the end of today's webinar and go through the audience questions. And I do believe that is it for the housekeeping items. So let's go ahead and move right on into today's webinar, which is building your data streams for all the IoT. Our speaker today is Craig Hobbs, who is solution engineer at Influx Data. Hey, Craig, how you doing?
Good morning, afternoon, evening, Charlene. I'm doing well.
Great. Well, I know you've got a great presentation to get to, so I'm going to put myself on mute and let you get right into it.
Thank you, Charlene. Thank you for the introduction, and welcome everyone, and thanks for joining today. So today we'll be talking about building reliable data streams for IoT, and specifically focusing in on the area of manufacturing, industrial automation, shop floor systems, and how you can use open source projects and products to create these types of reliable data streams through these types of simple and easy to use projects. So with that, let's go ahead and move forward, and I'll tell you a little bit about me. As Charlene mentioned, my name is Craig Hobbs. I'm a solution architect here at Influx Data. A little bit of information just there about me, some of my online personas and links. But I always kind of start off with the idea that I fight for the users. So I'm certainly dating myself here with that reference. So for all of those 90s, 80s Tron fans like myself, fighting for the user just really represented the idea that there's somebody out there inside the system always trying to do the best they can for the user. And that is really where I try to represent myself all the time. So hopefully today we will again fight for those users. So diving in a little bit today on kind of what we're going to go over and what we're going to discuss as part of our agenda. So what we're going to kind of walk through today and talk and learn about, certainly some of the challenges that are related to that IoT use case. We're going to take a close look at those and how we can address those. Take a look at some of the, talk a little bit about what the data is that's involved in the challenge with this use case. We're also going to look at some basic design around setting up some collection using some of the open source products and features, and kind of talk about what that looks like in a live demo session, and then we'll end with a little bit of Q&A. So with that, let's kind of go ahead and get right to a statement of the obvious, if you will, and that's that looking at time series data today is indeed for IoT all time series data. So what we really mean by that is that the data itself is anchored with a timestamp as it is being collected. And that really allows for, so whether your data is coming from your smart systems, your smart devices, your autonomous cars, your PLC controllers, all of this data is being collected quickly with a timestamp. And having that timestamp really allows for a lot of the downstream processing, analytics, and process improvement that collecting this type of data brings. What we see in those traditional architectures from manufacturing, from shop floor systems, is that this time series data is ultimately collected into operational systems called historians, where the data is then made available generally to the operator within the shop floor for other process improvements, for other field operations, and for other enrichment. But that is the flow we see from that time series data in those IoT and industrial automation workflows. But with that does come a large challenge of how this data is ultimately being used, and there is so much massive potential and explosive value in this data as it's being collected. There, with all the new innovations for being able to do product defect detection, do product workflow automation, to provide additional monitoring and alerting. The value that's in this data across the enterprise is exploding as this data is collecting and as the edge of the IoT is being pushed. But at the same time, we're seeing a case of vendor lock-in, and where that comes in is that the vendors that are producing all of these different sensors, all of these different controllers, are not looking to monetize this data in any way. So there's really no incentive for them to make this data open, to make this data useful throughout the enterprise. It's really at this point designed for that specific location of the operators who are using the data on the shop floor or in the field. So with the demand for the data growing with every day, but the lock-in and the drive of the vendors, there's really a huge challenge with this data, especially with the enterprise looking for different ways to further innovate, to further create processes and procedures to gain a competitive advantage. Finding ways to get to this data is really driving the challenge. So, kind of taking a look at what our path forward is here. So, what that challenge kind of set. What can we really do? What can we really expect from automation and the manufacturing sector to address this? So, what I'll talk really briefly about first is just OPC data and what role it really plays in the world of industrial manufacturing and how that data is being utilized to help with this challenge. So just a little background on OPC. It's really OPC itself is a collection of standards for interoperability and machine-to-machine communications. It was founded as a foundation of different manufacturing companies back in the late 90s to really kind of allow for some form of controlled, standardized communication for all of these different manufacturing systems, sensors, for exactly this type of communication. But it was originally founded on OLE technology. So for all of those who got my Tron reference, you might know that OLE is really that Microsoft technology that dates back. And again, it created that environment of technology lock-in. While it did open up certain standards, it did open up certain interplay, it really locked you into that Microsoft technology and platform. So what the foundation then came together and came up with is OPC UA, which means unified architecture. And now it was taking all of these classic standards and specifications, putting them all under one framework, and now opening up that communication channel to allow new service architectures to come in, new programming languages, new technologies like web services to be able to communicate. So now, not just a framework for machine-to-machine communication, but machine-to-machine and machine-to-enterprise. So there's a lot of history that goes into this foundation. Lots of major companies and corporations play in that foundation. Just kind of a look here, but certainly I'd invite everybody to take a look at some of the background. But what it's kind of brought us to is in this path forward is this new framework of OPC UA. So I always think a great way to kind of get some background into what that really means and what that's kind of brought about is sharing some of the use cases that we get to engage with customers. And one of those use cases is working with energy company and wind turbines. So in this photo here, this photo actually tells a great story, just in its simplicity alone. What you have here in the middle of this photo is a wind turbine, and ultimately what we have from this is the idea that the wind turbine itself represents a significant investment and cost for the energy company. So it is very key to them to be able to understand and improve on the performance of this wind turbine. These investments are not investments for 2 years, 5 years. These are 10 years plus. So it's very key that energy companies get the most out of these types of investments. So knowing where defects or failure rates may be coming so that actions can be taken as soon as possible are really key to this enterprise. Also, in the case of a wind turbine, one of the hazards that's associated with it is the idea of ice buildup on the blades. So when we think about the changes in temperature and where these wind turbines are being built and established, when ice builds up on the blades, as it melts, it can be thrown from the blade and actually be a hazard to passerbys in the area, to property in the area, and cause lots of damage and even physical injury. So it's very important for the energy, very important for operators of the wind turbines to understand what the weather conditions are when that ice buildup occurs, so that they can cease operation or change the operation hours, kind of based on the traffic that's there. So all of this information now is now being accessible with standards and frameworks like OPC UA. At first, you'd have to be an operator right there to make that type of decision, but now if that data can be accessed and monitored, that decision and that workflow could completely be automated. So these are the types of use cases we hear commonly in industrial automation and manufacturing. How can we help the operation of these sensors, of these different devices in situations where we want to get the maximum performance out of our investment, or we want to avoid injuries? So that's really what OPC, the OPC UA framework brought about. It really created that path forward for communications between machines, for communications within the enterprise, allowing for new automation, new ideas, new unique business cases. It removed all the barriers that existed in the traditional OPC framework that were created originally around the Microsoft OLE standard, and it really allowed for more vendor activity, vendor creativity, vendor plug and play. But there were still challenges, as with any framework, that when you start encompassing lots of different standards, lots of different organizations, it really became quite clunky. So OPC UA, while it was still developing in its early moments, was really quite clunky. It lacked things like real-time processing. So for being able to interact with that sensor data, with that time series data that we were just speaking about, it really became more about sampling that data or finding operational ranges when to look at that data. So you couldn't look at the full resolution of data. So with the exploding idea of machine learning and analytics, you were really sacrificing a lot of the data that you would use to make decisions around defects, around failure rates, around peak operations and performances. Couldn't really get access to all of that data. Just the standard didn't really allow for it. It didn't really give you that full access. And then there weren't really a lot of tools still taking advantage of it to really bring that data into the enterprise in a modern way. But now, lots of tools, lots of open source options have come about. And one of them I'll mention here today is Patchy NIFI. So for Apache NIFI, just a little background on what it is. It's really an event processing platform. So really designed around the collecting and curating data in real time. So it's an open source project out of the Apache software, and it's really caught on and become a very popular project. And it includes a lot of what they call processors. And these processors allow for collection and connection to different platforms, different protocols. So by bringing in Apache NIFI, you can easily plug and play different connectors, different processors for connecting and accessing data across varying protocols. It has a drag and drop UI interface, which made it really nice for non-developers to be able to create these types of event processing workflows. It also comes with scalability, guaranteed message delivery, all the things that make a event processing platform strong and scalable. So also there is Influx Data. So what would be a webinar without Influx Data? So full disclosure, I am a member of the Influx Data sales team. So that always brings to me the joke of, how can you tell if a salesperson is lying? Well, their lips are moving. So, and if no one's laughing at that joke, that's what makes webinars great. I never have to worry if someone actually thought my joke was really funny, but that's what makes webinars great. But as part of the sales team, I'm actually focused on the art of the possible. So I'm here to really kind of share and exchange and talk with individuals to understand what makes their drive. So while working on Influx, I do believe that Influx, there are absolutely many options for time series databases on the market, but Influx gives you a real strong combination of ingest and performance. It's built from the ground up for read-write optimization, really focused on that time series, on time series data. And in addition to that, as part of the project itself, it is an open source project. It includes Chronograph for visualization and monitoring. There is a co-processing engine below that to work with alerting and downsampling of data. But in addition to that, because it is an open source project or community project, there are a number of sources for connecting and ingesting data from that OPC UA framework that we were talking about. So everything from being able to collect the data to also projects that talk back to those servers. So now you don't have to only just collect the data and be able to monitor it and integrate it. You can actually talk back and instrument that data and send back commands and actions to automate those actions. So when I think about our windmill kind of example, there's the idea of being able to monitor an alert and get that information, understand what the performance is to prolong the life of the asset, but also now being able to go back and say, integrate with data outside and say, hey, the weather condition's changing. We're going to change the operation hours of this. So much potential now in kind of bringing together these open source projects to communicate with these sensors and industrial automation. So kind of just taking a look at bringing these two projects together and some of the power that you get in kind of combining them. Right away when working with customers, the thing I always point to is that by bringing together NIFI and Influx, you'll create a reliable data stream. So what do we mean when we say a reliable data stream? So we're looking at data streams that are secure, real-time, scalable, guaranteed delivery, and ultimately durable. So you get all of that when you kind of bring together just these two open source projects. So now by establishing a data stream that is reliable, you can also do this in a very easy and quick time to awesome fashion. Open source projects really allow for the idea of no development required, no engineering required, no services work required. You can really just kind of bring it out and you have the support of an entire community for updates, fixes, or just your own plug and play. And it also then provides for a wide range of supporting those unique business cases. So we kind of talked about, not only just being able to monitor the performance of the asset, but how can we now perform business analytics on this data that we're collecting from the various sensors and controllers to better optimize and take advantage of the resources that we have in our enterprise. This becomes a competitive advantage for so many customers in manufacturing Just kind of taking a look at some of the things that I was speaking about when I say, bringing Influx and NIFI together, really kind of add to that stack of things that you can you really get everything from, again, that reliable data stream to better storage of your data. We talked a little bit about the idea that in some of the traditional systems, operational systems and historians, there's still a practice of sampling data or loosey data where you're just getting approximations. But with a time series backend purposely built like Influx, you'll be able to take in all of the data in a real-time fashion, optimize the storage on the back end, then using tools like NIFI to collect and curate, but then having a tool like Influx that'll help shape that data so that it'll have a larger usage pattern for the enterprise. So when this data comes in now with tools like NIFI and Influx, you'll be able to provide a shape of that data that the enterprise can use in reports and analytics. And just some other advantages. Really bringing together open source projects always inspires so many advantages, and I get an opportunity to speak with so many customers about the art of the possible. And just some of these are from just working with customers in manufacturing, in aerospace, in mining. I've had so many I've been able to spread out with and just kind of take in different points of some of the advantages of bringing these together. And I think some of this on the list, some of the things that really stuck out is just being more open. I spoke a little bit about vendor lock-in in the beginning, but now what you're able to do is say with vendors having no motivation or no priority on this because they're not monetizing on this data, we now can be more open, not only just from the open source community, but just more open in the idea that this data can be moved across the enterprise, whether no longer just local to the shop floor, wherever your enterprise lives, whether it's in the cloud or whether it's in another data center, another field center, being able to share this data. And also no development or coding. I think that was another great one that was shared with the team at large. Being able to just kind of take this out, be able to deploy these in a time to awesome, up and running in 30 minutes, an hour, as opposed to long implementations that come about. So this really kind of gives you that ability of no coding, just up and running, combining together the best of breed. So I want to take a little look at the basic setup of what it looks like to bring NIFI and Influx data together. So kind of just of a basic collection. So there's so many different ways to deploy NIFI, deploy Influx. Influx can be deployed at the edge as well as NIFI. Can be deployed more as a centralized resource collection point. So really a lot of flexible ways to collect the data using both of these open source projects. But in a basic collection scenario, you'll have your OPC server that's admitting these metrics. But now your NIFI collection point will be able to, using the OPC processor from NIFI, you'll be able to now tap in, collect the data from the OPC server. And again, you'll be able to collect at much higher frequencies than you could with some of the traditional operational systems. So in some cases, you may want to monitor your device or windmill at the second precision, but now you might want to monitor at the nanosecond precision, kind of depending on what type of performance stats or monitoring you're doing for it. With this type of reliable stream, you'll have that ability. NIFI will be able to bring the data in, and Influx's real-time streaming, real-time optimization will be able to take all of that data in full resolution. Once it's transferred to Influx, you'll have the ability to share that data across the enterprise, do more monitoring, do more anomaly detection, and do further processing and shaping of that data to share within the enterprise. So what I like to do is actually kind of take a quick live look at what that might look like in a simple scenario. So let's transition over to some of the pieces that make up the basic collection. So what I'm going to do is I'm just going to pull us over to another screen. So hopefully everybody sees my new screen. So what we're looking at right now is a NIFI canvas. So this is I actually have NIFI up. I'm running it in a local Dockerized container. So again, very fast, very easy to bring these tool sets up. But I now have a NIFI canvas. And the reason I wanted to kind of showcase this again is to go back to that idea of when I get the opportunity to talk to lots of manufacturing, a lot of manufacturing field engineers, a lot of program managers that are in charge of manufacturing. They're really looking for something easy that doesn't involve any heavy intrusion or changes to the systems already have set in place. And that's why I say bringing together the best of breed of open source gives you that option. So now from now looking at something like NIFI and having a canvas, it really becomes all about drag and drop. So I can simply drag onto my NIFI campus and go and select my processors. So in this case, I want to tap into OPC UA data, so I can select to grab a OPC processor. And the first processor I have here is what we call get node list. So this actually will go out to the server based on your definition and grab either an entire node list branch, or it can grab specifics from a tree within the OPC server. So it's a really flexible processor that NiFi provides. There's lots of great documentation that shows you step by step how to go through it and get it up and running. I'm just going to go through a few basics, but at the end, I have some learning resources and some links where you can go out and you can see step by step how to set up everything on these processors. And it really is just as easy to drag and drop and produce, drag and drop and start. I'm also going to just add one more processor here. And again, the idea is just to really kind of show that this is the type of, add that one, really just kind of show that this is the type of product combination where you can kind of quickly put together that reliable data stream. That reliable data stream that gives you the full data resolution, and now you'll be able to monitor, share amongst your enterprise, and do alerting. So if I had my setup here now, I can just simply drag and drop to connect different aspects. So one is my node list. It'll actually go out to the server, search through the different nodes within the OPC server, pull back the different sensor nodes. The other one is the data. It will actually collect the data, and so it'll actually collect the data into a CSV format, and then I'll continue to add nodes that will then move it on into Influx Enterprise. But just kind of giving you an idea of what this looks like. You can now go in and just define properties. Again, no coding. It's just the idea of selecting on the properties. I would define what you call a service in NiFi. And basically what a NiFi service gives you is a shareable resource, a shareable session resource. So once you define a service, this service can actually be shared amongst other processors that you would define in NiFi. So while I'm looking at my canvas and I'm only looking at two things, you could have multiple processors, multiple workflows taking place simultaneously. So a shared session makes that very good to use. I can then apply that service and then actually come out and enable that service. So now this would tell NiFi to go and connect to my OPC UA server. If I actually click on that, there are options within NiFi to go and define my service endpoint. So I have a OPC server running. I can define security policies around that. So again, this is not just connection as part of that reliable stream, being able to create secure connections. And you can also add in additional properties that define that security and connection. And then I can simply go, and if I want to, and what I'll do here really quickly is I'm just going to give it a different name for uniqueness. So all of this can be defined So you might actually wind up having multiple OPC processes depending on what you want to do with the data. So now with that, I can come out and I can just go ahead and enable. And when I'm clicking on enable, I'm simply just telling NiFi that go ahead and establish a connection to my OPC server, and NiFi will actually go ahead and establish that connection. So now NiFi's established that connection, but I haven't turned it on yet. And that's another great feature of NiFi as a project. And it has a feature more akin to what I would call warm deploy. So even though all the services are running and everything is set, I can choose which pieces to turn on or turn off or disable. So I can actually turn on one piece while still leaving another station disabled. Where that becomes very valuable is that ultimately, if I needed to make changes on the fly, I could do such a thing. So now I can see I have data coming in. You can see I have a couple of records. They're not being passed on, and that's great because I could continue to make changes here while I'm still collecting records. So again, all of this gets into that reliable data stream that I spoke about. I can actually go in and see the data as it's being moved in actively. So this is, again, another piece of NiFi. NiFi is actually placing the data into what it calls flow files. Again, this gives it a durability setup. I can view what I'm actually collecting. So I'm actually just collecting everything that's coming off of the node setup, everything that's coming from my OPC server. So I can actually go in now and say, you know, I only want things coming from this particular sensor or this particular device. I don't have to take everything. So you have a lot of control over what you're going to do with it. And let me bring up my NIFI here. I just had it up. I just have my NIFI up here, so hopefully I didn't bring it down. No worries, I'll just go back to it. Accidentally closed my NIFI window, so I'm now back. And even though I'm back, close my window, still collecting, nothing's wrong. So that's what really makes NIFI so powerful. I can then stop it if I choose. And you can see I've been collecting all of this time, nothing's changed, but I actually just went ahead and stopped NIFI. So now I can kind of keep adding on to this to ultimately build out the stream. So in a true cooking show fashion, what I'll do here is just kind of jump up to a fully built out example collection stream. So again, I have all of those same pieces. I have the node to get the OPC data nodes. The only thing that's different in this one now is I've actually gone out and defined a list of nodes that I want to collect. I don't want to collect the whole tree. I don't need it. I could, but I don't need it. I just want to collect the data I'm interested in monitoring at this time. But again, with this type of stream and a time series backend, you can absolutely collect more data at full resolution. From that point, from the same point now, the next thing I've added is the InfluxDB backend. So again, this becomes another NIFI processor that allows you to connect up InfluxDB by simply defining yet another service, kind of similar to the NIFI service. You'll define an InfluxDB service, and this service will define the connection to InfluxDB. So again, this could then be reused in other workflows within NIFI. So I could come here and it simply gives me my connection to InfluxDB, all the security, all the credentials, where the endpoint is. So this becomes yet another session service that can be reused. You can add other pieces to it. I've done this I've done a kind of a simple example, but you can see just through drag and drop, if I wanted to monitor things like error logs, if I wanted to monitor things like retries, I could simply just tell InfluxDB that I want to monitor all of these things and continue to add to it. Once I have everything added to, I could simply go in and now say, I'm going to start my entire workflow. And with one click, I've now started my entire workflow. I'll move this over here so you can see a little bit more. So I've now started my entire workflow, and you can see I'm starting to collect and instantly bring that information into InfluxDB. So I could do this at full resolution. I can do this at second. I can do this nanosecond. So this represents a big change from what you traditionally see with those type of operational historians, where you're only collecting at certain ranges, certain intervals, certain sampling. I can now say whatever the server is putting out, just continue to feed me that data. I know I have guaranteed delivery through NIFI. I know I have high ingestion through Influx Data. But now that next piece is to start looking at what I can do with this data for the enterprise. We talked about how valuable this data is. What can we now start doing with this data in the enterprise? So what I'm going to do here is one more screen switch over. And actually now I'm going to InfluxDB. So this is another piece of the InfluxDB open source project. This is Cronograph. And Cronograph is the visualization layer for InfluxDB. So now that you're collecting this data, you could use tools like Cronograph to go in and explore the data, set up dashboards for monitoring, share this amongst the enterprise, establish alerts, and start to build your workflow automation so that you can send instruction sets back to the various servers. But if I come in to my setup here, I have dashboards running as I'm collecting data. Let's just say data for the last 5 minutes. What am I looking at? And we'll keep refreshing that data. So now I'm collecting data on temperature, on fan speed, on sensor pressure as it's flowing in. So now I get a real-time look at my data as it's flowing in. And in the past, what this would really represent for Industrial automation is a snapshot of over time, or a snapshot from a sample of data, or a snapshot from a range based on a change in the operational sensor. But now I'm looking at the data as it's happening, as it's flowing into the system. And then while collecting this data, I can also move over and start creating alerts. So if I wanted to create alerts on sensors and temperatures, I can start monitoring the actual sensor directly from within Influx. We have our co-processor that's also part of our open source project, known as Capacitor. You can establish alert thresholds to monitor the various sensor changes over time through ranges, and then dispatch those alerts directly through Capacitor. Our open source project includes lots of data integrations with things such as PagerDuty, OpsGenie, VictorOps, HTTP. So now you're collecting this information from these shop floor systems, from these manufacturing systems, and alerts can be dispatched. Alerts like there's a change in weather, or alerts like there's a performance defect rates are reaching their limits. All of these now make this data far more effective. It was always valuable. Now we're making it actionable. And then finally, as I come back, I can start to see some of my alerts are popping in. I can see I'm starting to get alerts back from the sensors in the setup. I'm continuing to monitor. I'm getting my fan speed. All of this information is coming in real time. So again, just kind of taking a look at what you can get from a combination of NIFI and InfluxDB as a backend for that type of industrial automation, manufacturing, monitoring in this space. Again, these are operations, these are projects and tool sets that are free, that roll out with no coding, no development, and that really open up this framework so that this data can be taken out of these traditional workflows that were targeted just at operators, just at shop floors, and now be used throughout the enterprise. So with that, kind of coming back to a few points again, we took a moment to take a look at Chronograph and Capacitor. So Chronograph being the visualization layer for Influx, again, part of the open source project that makes it easy to view data, do monitoring alerts. Again, these can be shared amongst the enterprise, and then also set up real-time alerting and stream processing of that data using the Capacitor project provided by InfluxDB, and then dispatching the alerts to different integration forms. Yeah, so really kind of bringing it back to the idea that bringing together the best of breed of two different types of open source projects, NIFI and InfluxDB. You really take those traditional capabilities that you see in those operational systems, and you're able to now really fully leverage the value in that data. You're able to observe, act, and dispatch throughout the enterprise. So we're seeing a lot of great organizations, a lot of great, again, from manufacturing to internet to high tech, really start taking advantage of these combinations of tools, specifically time series and a way to create reliable data streams. So I'd really advise anybody to check out what you can get from this type of combination, bringing these two types of projects together. And there's definitely a lot of resources that we can share to get you going. Everything from the various tool sets that you've seen here that you can download, to other video sets and blogs and other community projects that are really not only doing what we're doing in just this simple collection example, but really now taking these same projects and advancing them out. So that's a little bit about the project and the combination of tool sets we brought together. Really excited, and again, getting a lot of traction with lots of different organizations and operations. So I do encourage you to take a look at some of the resources, but please reach out. Again, we're all about working and exchanging and discussing the art of the possible, and looking into new options for combining up these types of projects. So again, thank you, Charlene, for kind of setting me up and introducing me, and love to see if there's any comments or questions from the audience.
All right, great. Well, thank you, Craig. Do want to remind the audience, if you have a question for Craig, just go ahead and use your GoToWebinar control panel and submit your questions. We do have a couple here we can get started with. The first one is, can I put my contextual data in InfluxDB?
Great question. Yes, you can put your contextual data in InfluxDB. So when I think about what we were looking at today in the example, we were focusing on metrics and events that are emitted from the various sensors, controllers, SCADA systems that come from manufacturing automation. But now you can also put that type of contextual data alongside it, log information, other description information, maybe information that comes from other relational databases. Influx supports connecting to those separate sources, as well as collecting information, collecting log information. So now you're not only driven by just the metrics and events that are coming from the systems. You can, within that same visualization tool of Chronograph, swivel over and see the actual contextual data that is associated with the sensor or with the metric or event itself. So that's a very powerful use case in Influx, bringing the metrics and events together with the contextual information.
All right, great. Next question. How big is InfluxDB? Can it sit on the edge?
Yes, so that's another great deployment and flexibility architecture. Both Influx and NIFI provide distributions that sit on the edge. So Influx, the entire Influx stack can be run on device types as small as Raspberry Pis. So we have several customers who will use Influx at the device edge to collect, aggregate, and downsample data because they'll now be able to collect the full resolution of that data, make the decisions right there, and then pass it on. Or they'll be able to use Influx's full stack on their smallest devices. So it really provides for a flexible architecture.
I like that.
Flexible architecture and workflow for deploying Influx. But NIFI also provides what they call a MiniFi for deploying on the edge as well. So lots of clever architectures there. Would love to discuss some options.
Awesome. Okay. All right. Great. Next question. Is there a trial version available on the cloud to try it out?
There is. So we've recently released our latest 2.0 version of Influx in trial. So it comes with some of our latest innovations, including Flux, which is where I got my flexible at. It comes with Flux, which is our new query and development language that really helps you do things with time series data that you couldn't do before with just SQL. So it brings together the best of working with time series data, and we understand the unique format of that, with also being able to bring in relational data and do it all in a language and a workflow that provides for a fully conditional functional language that helps you manipulate, aggregate, and do analytics on the data. So yes, there's for any and all attendees, please go and check out our free trial. In fact, we have a free tier of Influx. So if you wanted to sign up for Influx, you could get a free tier of Influx, free forever, and really just start kind of playing around with our cloud tier.
All right, great. Still plenty of time for questions, guys. So if you do have a question for Craig, please go ahead and use your GoToWebinar control panel and submit it. We've gotten a couple more in here. Next question is NIFI already, does NIFI already have the plugins for Influx 2.0?
We are currently working with our team to deploy the next version of the NIFI processors with 2.0. So I would expect them here probably by I think we're targeting early September for having the next versions for the 2.0 setup. In the meantime, there are ways to go about still using NIFI with 2.0. I would encourage if you do have questions about that, please just email me directly if you want to play with 2.0 and NIFI today. we have a process get you started, and it actually is extremely performant. But we're again, and I think this is what makes open source so so valuable. It's the idea of having just endless numbers of product managers going asking questions like this. Hey, do you have this for your 2.0 product? And what that does is send us right into motion and kind of create these together. So yes, please contact me if you're interested in using NIFI today on 2.0, but the native processors should be available shortly.
Great. Okay. Next question. It looks like a couple different questions glommed together here. So which IoT protocol is using the solution/platform to send data, like MQTT? And which IoT protocol do you recommend to send streaming data?
Yeah, so maybe unpacking that a little bit. So I think the question is which IoT protocol is using the solution platform to send data. So MQTT is one of those protocols that we see quite often as the message bus in between for passing on data. And it's probably the most popular one because it just provides a durable message queue for sending data. So and some more advanced architectures, MQTT will often sit right in front of NIFI as that message bus, and then pass the messages into NIFI that way. It doesn't have to, but it is a very popular protocol that we see as part of the overall solution platform. Kafka also comes into playing with that a lot as well too, but I think just in general, the MQTT platform is the protocol that we see of choice for sending the data. And as far as which protocol do we recommend, I think that's really a dealer's choice right there. From our standpoint, we recommend the protocol that gets you the reliable stream that makes the most sense for you. And again, a reliable stream being something that's secure, guaranteed delivery, real time. MQTT again tends to be the one that we see the most. We have plugins built for Influx to send data through MQTT, but we do have native plugins for protocols like UDP as well. You could also send data to Influx directly over HTTP. So lots of different ways to bring it in. I think MQTT is just emerged as the most dominant protocol, given that there's so many great distributions you can use of that in many different setups. Everything from Rabbit to Kafka, whatever message bus you want to use. But we certainly have more protocols than just MQTT that you can use.
Excellent. Okay, great. Next question. This is interesting. Wind turbine bearings wear out over time. Can you process vibration frequency filtering before feeding data to Influx Data?
The answer is yes, and that processing would happen in NIFI. So NIFI, one of the pieces of NIFI, it's not only for collecting and curating, it's also for full event processing and analytics. So what we see a lot in these processors is that in addition to sending the full resolution data on to Influx, you'll do pre-processing at that message bus phase at NIFI, because what you can then do there is dispatch a message back to the operator and one over to Influx as well. So you'll still have the full resolution and monitoring for the enterprise, but instead of waiting until it gets to Influx and having someone else look at there, you can have that processing take place right there on that platform and go back to the operator instantly. So you get really the best of both worlds. So yes, we see that quite a bit, not only in just industrial automation, but just in monitoring infrastructure, monitoring data centers. That type of workflow is very common.
Okay, great. Last call for questions. Guys, if you have one for Craig, go ahead and use your GoToWebinar control panel. Next question. Let's see. I use Cassandra today, so why would I switch?
Yeah, so Cassandra as a product, and again, this is all about talking through the art of the possible, and again, for so that I'm not shamed in sales, Influx is a great product for time series and rewrite query performance. Cassandra is certainly the right tool for the right job, but it is not a time series database, and what that means is it's not built purposely for optimization of ingest of time series data, that read write optimization. It tends to what I've heard from customers in the field is Cassandra tends to be a much bulkier install. It certainly comes with a lot of complexities. Influx really is focused more on storage optimization and compression. So we'll routinely speak with customers that'll have 12 Cassandra nodes where Influx has 1 or 2. Right, and that really kind of speaks to both the performance of time series and the storage optimization from the Influx approach. So the reason why you would choose an Influx or a time series database is certainly the right tool for the right job, far more cost effective when you think about how many nodes you need of Cassandra, and then I would say finally just the complexities of setting up a Cassandra or scaling that out into a cluster. Is really a turnoff when you think about the volumes of data you'll get from industrial sensors.
All right, great. Well, that is all the questions that we have. So I do want to thank everybody who did submit a question, and got some great stuff today, Craig. I got to tell you,
it felt great, and
yeah.
Well, yeah, no, Charlene, it really felt great. And I just want to say, I hope folks please reach out to me. Some of the questions were really great. Would love to dive into them a little bit more. Again, that's what this is, kind of open source, open community is really all about, is more exchange. There's some great things that you're doing or seeing, protocols you're working with. Certainly let us know. We'll exchange that out and talk even more about them.
Yeah. Well, I got to tell you, between Tron and the Wonder Twins, you kind of had my childhood pegged right there. So I don't know if our audience, got all of the references, but that's okay because, now they have some homework to do, I guess. But I do want to thank you for giving such a great presentation. Lots of great stuff. And you can always tell by the quality of the questions that come in how well the audience received it. So today was, you hit it out of the park. So good on you, Craig. Also, want to remind the audience before we close things out that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it or listen to it again, you have the opportunity to do so. We will be sending out an email after today's event that contains a link to access the webinar on demand. The webinar is also actually going to be living on the devops.com website. So you can always go there, check it out. Just go to devops.com/webinars and look in the on-demand section, and it'll be right there waiting for you. And while you're at devops.com webinars, please take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be 1 or 2 out there that pique your interest. Again, Craig, thanks so much for giving such a great presentation.
Thank you, Charlene, and thank you to all who attended. Really appreciate it, getting an opportunity to share some of the learnings.
Yes, I do want to thank the audience as well for attending. This is Charlene O'Hanlon, and I am now signing off. Have a great day, everybody.